Very good afternoon. This is Morgan, Assistant Professor, Department of Agriculture Engineering from Sri Shanmuga College of Engineering and Technology. Today I am going to present a topic on basis of fluids. Mechanics is the oldest physical science that deals with both stationary and moving bodies under the influence of forces. The branch of mechanics that deals with bodies at rest is called statics, while the branch that deals with bodies in motion is called dynamics. There are different subcategories in fluid mechanics are there. Here we are going to study the fluids which is at the rest, that is called as fluid statics. Where the pressure forces are not considered in fluid in motion, we can say it is called as fluid kinematics, and the pressure forces are considered for the fluids in motion, we can say it is called as fluid dynamics. The study of motion of fluid, they are practically incompressible, such as liquid, especially water and gases at low speed, we can say it is called as hydrodynamics. A subcategory of hydrodynamics is called hydraulics, which deals with the liquid which is flows in pipes in open channel. Gas dynamics, gas dynamic deals with flow of fluid that undergo significant density changes, such as the flow of gases through nozzle at high speed. The category of aerodynamic deals with the flow of gases over body, such as aircraft, rockets and automobile at high or low speed. Some specialized categories such as meteorology, oceanography, hydrology deals with occurring the natural flow, especially rivers, oceans and seas. Let me move on to the fluid. Just what is fluid? The fluid must be a substance which are existing in three different phases. One is solid, liquid and gas. A substance either in liquid or gas phase, we can say it is called as fluid. There is a difference between solid and fluids based on the basis of the substance which has the ability to resist an applied shear stress that tends to changes its shape. A solid can resist an applied shear stress by deforming, whereas fluid deforms continuously under the influence of shear stress. In solid, stress is proportional to strain, but in fluid, stress is proportional to strain rate. Here are the examples. When a constant shear force is applied, a solid eventually stops deforming at some fixed strain angle, whereas the fluid never stops deforming and approaches a certain rate of shear strain. Here we have a difference between the liquid and gas. Here the liquid is having the free surface. Above the free surface, there should have a number of there is atmospheric air, that is a gas we have. In liquid, molecules can move relative to each other, but volumes remains constant because of strong cohesive forces between the molecules. As a result, the liquid takes the shape of container and it forms a free surface in a container with a gravitational field. A gas, on the other hand, expands until it encounters the walls of container and fills the entire available space. This is because the gas molecules are widely spaced and the cohesive forces between them are very small. Unlike liquids and gases cannot form a free surface, but the liquid can have a free surface. These are the some differences between liquid and gas. In liquid, it is difficult to compress and often regarded as incompressible. And incompressible means the density of the liquid does not change with respect to time as well as place to place. Gas, it can easily compressible. Change of volume is large, cannot normally neglected but related to temperature. In liquid, it occupies a fixed volume and will take the shape of container. In gas, there is no fixed volume, but it changes the volume to expand it to fill the containing vessels. A free surface is formed if the volume of container is greater than the liquid. It is completely filled the vessel so that the no free surface is formed. We couldn't able to see the free surfaces when the air is filled in the container or any place. Some applications areas of fluid mechanics. Mechanics of fluid is an extremely important in many areas of engineering and science. So some of the examples are in biomechanics, blood flow through arteries and veins. This comes under the fluid mechanics concept. The passage of blood through veins from top to bottom, it comes under the category of fluid. There is biomechanics. Airflow in lungs, flow of cerebral fluid. In household, piping systems for cold water, natural gas and sewage. Piping and ducting network of heating and air conditioning system. Refrigerator, vacuum cleaner, dishwasher, washing machine, water meter, natural gas meter, air conditioner, radiator, etc. In meteorology, ocean and engineering, the movement of air, currents and water currents. In mechanical engineering stream, design of pumps, turbines, air conditioning, equipment, pollution control equipment, etc. Design and analysis of aircraft, boats, submarines, rockets, jets, engines, wind turbines, biomedical devices. These are some of the applications where this fluid mechanics has been involved, especially in transportations of water, crude oil and natural gas. In civil engineering, transport of river sediment, pollution of air and water, design of piping system, flood control system. In chemical engineering, design of chemical process equipment. Some of the applications areas like turbo machines, military, automobile, medicine, electronics, energy, oil and gas. Almost everything in the world we are contacting with the fluid or itself a fluid. And this is the applications area of fluid mechanics, where the missile aerodynamics and automobile aerodynamics. And this is another applications area: high speed train, wind turbine, a smoke from a stack, a pollutant dispersions over a city. And this another applications areas: propeller, fan, a centrifugal pump when it is getting to rotator, jet engine propulsion, cross flow fan. These are some common examples of how the fluid tends to move from one place to another place. These are some glimpses about the application areas of fluid mechanics, like sky jumping, golf, swimming. Yeah, swimming plays a vital role in fluid mechanics because we have to move the liquid particles from means from to and fro. Football, cycling, because based on the cyclic action, the centrifugal pumps it works. IndyCar racing. And next we'll move on to classifications of fluid flow. We are classified into different category. There's a wide variety of fluid flow problems encountered in practice now. We have some characteristics to make it feasibility to study them in groups. Viscous versus inviscid regions and flow. The internal resistance of the flow is quantified by the fluid property called viscosity, which is a measure of internal stickiness of the fluid. And viscosity is caused by cohesive forces between molecules in liquids and by molecular collisions in gases. So this is the viscous versus inviscid region of flows. So there is a boundary layer, free stream velocity, boundary layer. I think free stream velocity we take it as capital U, and after the boundary layer the velocity of the flow regain its original. So we have 99% of the original velocity can be regained after it reaches the boundary. This is about the compressible versus incompressible. Already I have informed. Compressible, the density gets varied with respect to the place, especially the temperature. In liquids, the density will not change with respect to place. That we can say it is called as incompressible flow. For example, a pressure of 210 atmospheric causes the density of liquid at 1 atmospheric to change by that 1%. Gases on the other hand are highly compressible. A pressure change of just 0.01 atmospheric, for example, a change of 1% in the density of atmospheric air, gas flows often be approximated as incompressible if the density changes are under about 5%. In turbulent condition, the flow starts moving in a zigzag way or zigzag manner. The flow of low viscosity fluid such as air at high velocity is typically turbulent, here moving here and there without having any undefined pathway or shape. A flow that alternates between being laminar and turbulent we can say the in between region, we can say it is called as transitional. And this is about the another classifications of fluid flow, natural versus forced flow. Here any external resources which has been used to send the water from one place to another place, example a pipe flow. Natural flow, we can say the example as the best example for the natural flow is about river.